Okay, so maybe intuitively you know that if your pollution is under the influence of a wind event, then that wind is going to help disperse the pollutants. And that's actually what this slide is talking about. The faster the wind, the greater the dispersion. If the direction varies, then it will be kind of swirly and the dispersion will be even greater. So your textbook has this picture of showing you, now I kind of laugh because why would you have, I'll point to the city over here, why would you have the city downwind from your factories? I'm not sure. But that's kind of what we've got showing here. Maybe it doesn't, maybe the prevailing wind isn't this way. But anyway, we're showing a wind of 10 meters per second. Okay. And then here we're showing a wind of 5 meters per second. And if you compare the 10 meters per second to 5 meters per second, definitely the one with the higher wind speed gives you more dispersion and less pollution downwind from the source. So the opening scene showed a city in China that was experiencing a severe pollution event. And most likely I had mentioned that it probably had some sort of temperature inversion in place that acted as a cap to keep those pollutants in. Now remember, one of the things we talked in this class was that usually within the troposphere we have, well, actually everywhere, usually within the troposphere we have warm air near the Earth's surface and it gets cooler as you go up. So for that reason, our warm air is less dense than the cold air above it. So one of the things we know about warm air is it tends to want to rise. So it's not like a crazy sort of uplifting thing, because we have that thing called hydrostatic equilibrium. But we generally tend to have kind of this sort of, the earth breathes, warm air rises. Well, if you have a temperature inversion in place, what's going to happen is that warm air might start to rise for a little bit, but then it's going to go up against a cap. It's going to have some warmer air up there, and then that air is going to want to sink. That's a temperature inversion. So this is showing you on the previous slide, I talked about two different types of temperature inversions. But what I want to stress is kind of just show you what happens. Here we've got a temperature inversion in place, and notice it kind of has a lid here on this smog, so it stays in place. Notice here we have the temperature inversion gone, and your smog gets to leave. One of the types of temperature inversions listed a few slides ago was the subsiding subsidence temperature inversion, where air that is descending will warm, and it will then create that warm inversion layer like you see here. Temperature inversions will trap pollutants.